Okay, so what we can also do is to actually check the opening price and then the closing, the closing price, right? For maybe the first 30 days or for the last 30 days, right? So for what we can see over here is for the first, for the first 30 days, right? So let me just walk you through a bit in the code, right? So here is just setting up the figure size, right? As you can see here, so we have the length to be 20, the width to be 10, right? And then setting the title to be Amazon, as you can see over here. And then the font size, the white tick font size that you can see over here, right? We're setting that, and then the white tick to be 20, we set over there. And then we set date and price, right? So we can see date and then price, right? So for Y label, or for X label should be price, should be dates, right? Should be dates. That's what you can see over here. For for Y label to be priced, that's what you can see over here. Okay, and then for the we are doing it for the last, for the first 30 days, right? For the first 30 days, and this one is to just select Amazon, right? To select Amazon over here, and then the label should be open and then close, right? As you can see for the label over here, right? As you can see over here. So this actually just to plot this so that you can see the opening and then the closing price within this period. But this one is actually 2015, right? Somewhere May 2015, right? So we're going to fast forward this, right? We're going to fast forward this to say 2020. So let's see, instead of the first 30 days, we can see for the last 30 days, right? So instead of the first 30 days, we can see for the last 30 days. So I'm going to change this to say, to start from the back, right? To start from the back, if you remember this. So I'm going to start from the back instead of starting from the first 30 days. I'm going to start from the last 30 days. So if I run that, now you can see that it's corresponding to this trend that we have here, right? So recently, this is what we have. So instead of 2015, now you can see that we are having 2020 over here, right? We're having 2020 instead of previously where we were having 2015. So let me go back so that you can actually see the difference between what was earlier on. So I'm going to undo this. I'm going to do undo this. All right, now you can see over here, right? This is what we were dealing with earlier on. So if I run this, now you can see those what the trend was, right? This is the opening and the closing. So the opening, and then the opening is the blue one here, right? And the closing, you can see that there was some drop here, there was some dropping, and then it starts increasing, and then there's another drop here, right? That's somewhere around 2015, right? So that's somewhere around 2015. But if we fast forward this and then come to the last 30 days, right? Come to the last 30 days. If we fast forward this and come to the last 30 days, now we can actually, if I run this, you can actually see that recently there has been an increase, right? You can see that recently there's an increase, right? There's an increase, although there's some drop somewhere, but still there's an increase, right? Especially within this time from maybe from March, April, right? Somewhere like that. So it has seen an increase, right? It has seen a drastic increase over here. Okay, so if you fast forward, you can see although there were some drop, right, in the opening and the closing price, but now recently there has been an increase. Okay, so that's another way of getting an insight from the data that you've collected. Okay, we can also see this, with respect to the day. We can also see it with respect to the days, and then we can see that although there were some drastic decreases, don't forget the movement. We have positive and the negative movement over here. All right, so you can also see that although there were some steep drops, but you can see that mostly it doesn't actually drop so much. It doesn't actually drop so much recently. There's if you see the days, right, you get into the end of the month there, there's a drop over there, right? There's a drop over there, but normally it increases again, right? As soon as it drops, it increases again, right? You can see that as soon as it drops, it increases again, unless around somewhere between maybe first to the fifth in days, you can see there will be a drastic decrease there, but getting to the end of the month, you can see that it's a bit stable, right? It's a bit stable over there. Okay. So we can also see the volume, right? We can also see the volume that happens within in the day, and I mean high volume. I mean the peaks, right? The peaks that you are seeing over here suggest that a high volume of stock traded on certain days, right? So these peaks that you can see over here are representing the various volumes that happens in the various in certain days in these years, right? In certain days in these years. So from 2016, see that there was some high volume somewhere here, and then all the way to 2020, there's some high volume here, right? There's some high volume here. I mean, I'm talking about the stock, right? The stocks that are being traded, in certain days, right? Talking about the stocks that are being traded in certain days. Okay, so you can see there are different volumes that have been the different peaks that happen. Some drops, right? Some drop, and then some also go high. All right, some also go high. And after 2020, I mean, there was a high spike over here, but it dropped. Right, it dropped, maybe due to the situation that we are in, right? Due to the situation that we are in, it affects a lot of things. So although it was going up, but there was a drop, and you can confirm it from here, right? You can confirm it here, but it has actually started increasing, right? It has actually started increasing, though it's not as significant, but you can see there was an increase over there. But the drop over here is possibly due to the outbreak of the disease that we are facing right now, right? Maybe it's actually affecting the stock market in general, right? I mean, it's affecting the economy, the general economy of the world in general. So possibly it's part of the situation, and it's part of the cause why this is actually dropping. All right. We also, after that, since we are dealing with, so we have several companies that earlier on we put in the dictionary, but we're going to concern ourselves with Amazon and Apple, right? You can do it for any of the companies and then compare them and then see how it is, right? Later on, when we're clustering, we will consider all of these companies, right? We're just taking these two companies and then drawing some insights from them. So you can do it for all the other companies that we have over here. You can do it for any of the companies that we have over here, right? So we're taking these two, and then we're making we're getting some insights from it. All right. So now we can see that the stock prices of Amazon and then Apple, they are not the same, right? They are not the same. They all have different stock prices, and they have different scales that we can measure them on. Okay, so in that case, we need to actually normalize our data. If you want to perform machine learning on this data, you need to normalize it so that they all have the same scale. And that's what you're going to actually do over here. All right, that's what you're going to do over here. Now, if you can see this, okay, let me first walk you through the code a bit before we come to the explanation of this. Okay, so as usual, we set the figure size, then we set our plot, right? One row, one column, the first position for Apple, right? So that's what is over here. The title is over there. The text, as you saw from the other plots, right? So X takes over there, Y takes over there. All right, so this one, instead of 10, now we're making it 18. That's why you see that they're almost the same, right? Unlike here that we said that unlike here, right, that we have the S ticks, let me go up a bit. Yeah, S ticks were 10, and then the Y ticks were 20. So you can see that the Y ticks being bigger, the S ticks are very small, right? But over here you can see that they are almost the same, right? 18 and 20, right? So you can see 18 and then 20 over here. Okay, so that is just that. And then the zero, we are plotting the zero to represent the Apple. So if you can see the data frame that we have over here, we are using indexing. So 0 1, so 0 for Apple, 1 for Amazon. That's what we're doing over here. All right, that's what we're doing over here, right? So we pick the 0. The data at the 0 position, we pick that, which is Apple, right? And then the one at the 1 position, that we pick that, which is for Amazon, right? Then we plot it. Now you can see the inconsistencies over here, right? You can see the inconsistencies, and of course you can actually see that also from here. from, you can see that 2474. If you do that for Apple, you can see now, you can see this huge value. Just keep your eye on this huge value here, right? If we do that for, we search for Apple, right? If we search for Apple now, you can see over here, right? You can see as small as that 293.80. Now you can see inconsistencies in there, right? So we need to normalize our data so that they will all be in the same scale, right? They will all be in the same scale. Now you can see that there's a significant difference in the rate of change of units in stock price of Amazon and Apple, right? In that case, we need to normalize our data in order to have consistency in our data for further analysis. So you can see the inconsistencies in that, right? So I've written it over here for you, right? In case you need the explanation, I've written it over here for you. All right. So let's now, I mean, the plot over here is actually confirming this, right? It's actually confirming this. So we're going to normalize it, and then we visualize it again and see how it's going to be. I mean, how it's going. We're going to do this for all of them. So we're just doing this for Apple and then Amazon so that you see it, because I mean, for all of them we cannot. I mean, it's 18, and I wouldn't want to do this one by one for all of them, but I'm going to do that later on, and that's the same way I'm going to do it. But we will not visualize it later on, right? We will just do it without visualizing it. That's why earlier on I'm doing this so that you can visualize it and then get an understanding of what we will be doing later on, right? So we're going to normalize it by using what is called the normalizer, right? So from scikit-learn.preprocessing, we're going to import normalizer, right? And then we initialize it here, right? We initialize it here, and then we fit and transform it on the movement. Remember, movement over here, we created movement. If you go all the way up here, movement is here, which contains the difference between the stock closing price and the opening price, right? You're going to do that, and then we're going to normalize that, right? Later on, we do the normalization for all of the data, right? So that's what we are doing over here, right? Then we can check the minimum and then the maximum values of this normalizer. Don't forget, when we normalize it over here, right? Normalizer.fit transform, and then the movement is here. When we do that, we store it in what's called the norm movement. All right, so we're going to check for the minimum, the minimum, and then the maximum, right? We're going to do that, and then we also check it for the mean. So let's print that, and then we'll see what we have. So if you print it out now, you can see that we have the minimum to be negative 0.335, and then we have maximum to be 0.265 or 266 if you want to run it. All right, and then we have negative 4.35. Don't forget we have E. All right, don't forget we have E here. We have E minus E to exponent negative 0.5, right? So obviously this is going to be very, very less number, 0. something 0.0000435 something. All right, so it's still very less. So all these values are just within negative 1 and 1. All right, so that's the normalization we want to do, and we're going to do this for all of the other features that we have in our data set. Okay, so after normalizing it, so you remember that when we plotted it earlier on, there's what we have, right? This the inconsistencies that we have. Now after doing that for Amazon and then Apple, if you see the plot over here, now you can see that it's normalized, right? And they all have consistency in their scale over here. All right, unlike what we were earlier on having over here, right? So the normalization helps us to have this consistency. All right, so now what we can do is to actually create a pipeline which will combine everything that we've been doing so far, right? So we're going to actually apply the k-means algorithm on this data, and we're going to use what is called the make pipeline, right, which will help us to combine. Instead of doing it one by one and doing the normalization for all of them, we're going to do all these in just one pipeline, right? You're going to make a pipeline, combine everything. So this is our k-means algorithm over here that we are initializing, and then we are giving number of clusters to be 5, right? Number of clusters to be 5, and then the maximum iteration to be 1,000, And then since it's going to be random, and it's going to be done randomly, we want the same random numbers to be generated over and over again. So we're setting the random state to be 1, and then after that we create our pipeline over here, right? So our pipeline is actually going to combine the normalizer that we have over here, right? Remember, we initialize the normalizer and then we store it in a variable called normalizer, right? So this is just an initialization here. So we're going to use that together with the k-means that we're creating over here. We combine everything together with the pipeline. All right, then after that we fit with creating the algorithm here, right? And then we make some predictions and store it in what is called predictions. All right, so if you for instance check what is inside this prediction, you can see that it's making some predictions of some of the clusters. Remember, we say that we're given 5 clusters over here, right? So now it's going to make some predictions on the different clusters that we have. So we will be having some 1, 3, 0, 2, 4. Of course, from 0 to 4 is 5 clusters. All right, so that's the kind of predictions that we are actually going to have. Remember, in this case, we are predicting clusters, right? We are not predicting, we don't have a target to predict, right? We are predicting different companies to be in different clusters based on their similarities in their stock market prices, all right, or in their stock market data. Okay, so that's what we are having over here. All right, so let's see the various clusters that we are able to make over here. So we're converting everything into a data frame, right? Remember, there's the predictions, right? We're creating a dictionary for that so that we have the title to be clusters, and then we have the name of the companies to be there, right? And then we print those names of the companies there. So if we print that one out, this is what we actually have. So it's over here, we've been able to group these or cluster these companies into different clusters, right? Into different clusters. For instance, Amazon is in cluster 2, Apple is in cluster 2, Walgreens is in cluster 1, Northrop Grumman is in cluster 3, Boeing is in cluster 1, Lockheed Martin is in cluster 4, McDonald's is in cluster 1, Intel is in cluster 1, Navistar is in cluster 1, IBM is in cluster 1. I mean, all the way to Bank of America also in cluster 4, right? So you can actually see these different clusters individually and see maybe you want to see how many, which companies are in cluster 2, you can do that. Which companies are in cluster 0, you can do that. Okay, so you pick in the clusters. If you do it like this and then you pick the clusters, right? For instance, if we pick only this cluster, right, and then see the various clusters over there, if we do that, that's what we actually going to have. I actually need to run this, right? I need to run that, and then run this, and then I'll run it again. Okay, now you can see this is what we have, but we want to see which companies are in there. All right, so for companies that are in cluster, say 0, so let's start from cluster 0. If I do that, we're going to have some true or false, but I want to see the names of the companies, so I'm going to do this. All right, I'm going to do this. Okay, so those are in cluster 0, right? Those companies that are in cluster 0 are those that I'm having below, right? So in cluster 0, we have MasterCard, Microsoft, Pepsi, and then Mitsubishi. All right, so these are the companies that are there, right? That's we have in cluster 0. So based on their stock market data, we've been able to cluster them into one group. All right, so you can check for, say, those that are in cluster 1. All right, so all these companies have been grouped into cluster 1. All right, Walgreens, Boeing, McDonald's, Intel, Navistar, IBM, Coca-Cola, Toyota, Sony, Exxon, and Ford. They are all in cluster 1 based on their stock market data that we got. All right, so in cluster 2, we have Amazon, Apple, Texas Instruments, American Express, Johnson & Johnson, and Chevron. All right, so we have all these in cluster 2. So we've been able to group these companies into different clusters. For cluster 3, we have these 3 companies. We have cluster 4. This is the last cluster. We have 3 companies over here. All right, so you can check for different, based on their stock market data that we extracted from Yahoo, right? Based on the stock market data that we got from here, we are able to cluster them, right? Using the k-means algorithm here, right? You can change the cluster. Over here we say 5, you can change it to say 6. If we do that, if we change the cluster here, you can see that now it's predicting. Now you can see 5 here, right? Remember, it's from 0 to 5, so 6 different clusters. So over here, if we put them into data frame, right, and then we come here, we can actually see now the maximum limit later on when we're having, earlier on when we're having 5 classes was 4. Now we can go for 5 and then see which companies are being put into 5 clusters. The feed cluster. All right, so we can see different classes here. So let's limit it to 5, which will make sense, right? Let's do that. We don't want to actually have so many clusters which will not make sense. All right, so over here, the last time, if we make 5 over here, we're going to get error because it's not up to 5. See, there are no companies in that, right? There are no companies in the feed cluster because our clusters are not up to 5. They are up to are not up to 6, right? If it's up to 6, then you have the feed because it's ranging from 0 to 5, we're just making it 6, right? Remember, the 5 there represent the seed cluster. All right, so the feed cluster in this case, since we want 5 clusters, the feed cluster here, if we run this, then we're going to have it. Okay. Now we can change the dimensions. We can reduce the dimensions, right? Because if we run this now, if we run the movement the shape, right? Remember we have this. Let me go down. Norm movement, right? If we're going to see, remember we normalized our data here and then we store it in norm movement. Let me go a little bit up. Yeah, now you can see over here norm movement is here, right? After normalizing it, we stored in that. Now if we check the shape of that, right? If we check the shape of that, we can see that we have 27 rows, but we have 1260 features or different columns in this, which is too much, right? The features are way too much to deal with. So we need to reduce the dimension, from this 1260, right, to say 2 dimensions, so that we can actually visualize it and make the computation faster. Of course, there's a disadvantage with using PCA, which of course this is going to generate features from the existing features, all right, and it's possible that we might lose some formation, but it's actually computationally easier to do, and we will be able to visualize it. So we're going to reduce it from this 1260 to a 2-dimensional space that we can actually visualize. So that's what we're going to use, what we're going to do over here. So you can see that from scikit-learn.decomposition, we are importing PCA over here, and then the same thing that we did earlier on with our normalizer here, initializing the normalizer, the same thing we're going to do. So instead of let me go a little bit up. All right, instead of just using normalizer and k-means, now we're going to do PCA. So we add PCA to this, right? So that's the only difference that we're going to have. All right, so now we're going to initialize our PCA, right? So PCA and then the number of components. So instead of 1260, we are setting the number of components to be 2, so that we have a 2-dimensional space to actually work with and be able to visualize. Of course, we want 5 clusters as we did earlier on, right? So it's just the same thing that we're going to do, but just reducing it, using PCA to reduce the dimensions, right? And the max saturation, everything the same. Now if you see the pipeline, make pipeline, now we have normalizer PCA here, right? Or PCA data. Remember, we are initializing here our PCA and then storing it here in the PCA data. That's what we have over here. All right, and then the k-means is there. So earlier on we're having only k-means and then the normalizer, right? If we go up here, you can see that we have k-means over here and then the normalizer. That's what we were dealing on earlier on and making some predictions. So we're going to do the same thing, just that we are going to reduce the dimensions, right? So the same thing over here, fit on the movement, make some predictions, and then after that convert it to a data frame, and then we can also see the dimension, the various clusters that we have. In this case, we are actually sorting it, right? We are sorting the values, right? And then we sort it by the cluster, right? So that we have those that are in zeros, those that are in ones. Remember earlier on we did not sort it, right? We don't have any sort over here. There's no sort after this, right? We just printed it, and then later on we manually selected those that are in 1, those that are in 0, those that are in 4. But in this case, we are sorting it so that we see those that are in 0, those that are in 1, those that are in 2, those that are in cluster 3, those that are in cluster 4. All right, that's what we're doing over here. Now we can plot the decision boundary and then actually visualize these clusters, right? So that's what we are going to actually do over here. So if you visualize it over here, you can see that we have 1, 2, 3, 4, 5. So let me just maybe give it a number wise, maybe 1, and then let me off my time, maybe 1 over here, maybe 2 over here. You can see 3 over here. We have 4 over here, we have 5 over here. All right, so you can see we have 5 different clusters over here, right? With their different, we have centroids, right? We have different centroids for all of them. All right, we have different centroids. So we have 5 different centroids which are helping us to cluster these into different classes. So this one is just a visualization of what we just did earlier on, right? So this is our target here, to actually be able to cluster these companies according to the stock data that we have. All right, so if you want to go through this code too, I mean, this is just the PCA. It's just the same thing that we did here, but in this case we want to do it and then plot it at the same time, right? So PCA is here. Instead of maybe using the pipeline, in this case we are not going to use the pipeline. We just fit and transform straight away on our data. All right, on our data, and then over here we fetch the maximum, right? We store the maximum here in this x mean, I mean the minimum over here, right, in this x mean, and then the maximum over here, right? We store this maximum here in what is called the x max. The same, we do the same thing for y, right? So maximum in y, we do the same thing, store it in y mean, I mean minimum in y, we store it in y mean. All right, and then maximum in y, right, we store it in y max. All right, the same thing that we do in, and then we use this mesh grid. I mean, if you're not familiar with this mesh grid, it's not anything big. I mean, you can just use this, right, and then you can just get the information from, I mean, the documentation, right? We go to the documentation here for the mesh grid. I mean, the various parameters that you're able to use and what we use for. I mean, you can just take 1 minute and then just read about that. Okay. So that's what we are using to actually draw this one, and then with this h equals 0.01, that's the mesh that we're using. That's what you see, these squeaky lines over here, right? Let me get rid of this. That's what you see, these squeaky lines that you're seeing over here, right? If you change the size, it's actually going to give you a different thing. Right, it's actually going to, you can make it maybe 0.21 so that it will be a bit smooth. All right, if I run, I have to actually run this one. Okay, now you can see that it's a bit smooth. Now you can see that it's smooth, right? So it's just, you can just play around all these things that I've been using over here, right? You can just play around with any of these, right? So this is just making predictions using the k-means, right? Making predictions over here. It's just the same thing that we've been doing up here. We just combine everything and then we've been able to plot it, right? And then using this IAM show to actually make it visible, and all these are just hyperparameters that you can tune, right? Just k predictions are what we have here. So you can just manipulate all these things, right? With this x mean, x max, and everything is just what we're doing up here, right? With x mean and x max. And I mean, they are all hyperparameters that you can tune, setting the title, the centroids, all right, and then finally showing it. So all these are hyperparameters that you can tune. Our major aim here is to actually be able to cluster different companies into different clusters. And as we can see over here, we've been able to cluster these companies. All right, we've been able to cluster these companies. All right, we've been able to cluster these companies. For instance, this one, we've been able to cluster this one. Right, cluster them into different, let me undo this. Okay, so you see that we've been able to cluster these into different companies. We've been able to cluster these, this one actually, not up to this. It's just from Mitsubishi to all the way to MasterCard in one company, from Chevron, and all the way to Texas Instruments, and then you can see IBM all the way down. Let me undo this and then push it up. Okay, yeah, you can see now, you can see Very well, right? Let me get rid of that. So our major aim is to be able to do this thing that we are doing. All right, our major aim is to be able to cluster these companies. Okay, from Chevron all the way to Texas, from IBM all the way to Valero Energy. See that they are in different clusters, and then Ford and Pepsi are in different clusters. So this is what we want to do, to cluster these companies, right? To be able to create this cluster, right? And that's what we are able to actually do over here, right? And that's the major aim here, and we've been able to do that. Okay. So you can actually change. Now we did it for this year, right? From this year 2015 to 2020. Now you can change it depending on the time and the time that you are accessing this video. You can actually change everything here. All right, and then fetch the data live from the Yahoo site, right? You can fetch it from the Yahoo site, and then you can analyze it and then see, right? And then compare and then see how it's working. You can even choose different companies. You can change these companies and then choose different. And as I said, you can use this data reader to read it from, say, Yahoo Finance, from Google Finance. So instead of Yahoo Finance, you can change this to Google Finance, right? So instead of here specifying Yahoo, maybe you can specify Google, right? You can do that. And then I mean, you can change and then manipulate it according to your own how you want to actually visualize or see this, right? So I mean, do this, practice it. I mean, change everything that is here, manipulate everything, just play around it, and then get an understanding of be well equipped with fetching data on the internet and manipulating it and gaining understanding of the various companies based on their stock information, or based on any other information that you require. All right, so see you in the next project. Bye bye.